Hey guys, this is going to be 9.2 on similar polygons. We're going to be doing quite a bit with this topic. The whole chapter is on similar triangles, and similar shapes in general. So we start getting into what the word similar means now. So we remember what congruent means. Something that's congruent, say we had two triangles that were congruent. That means they had the same shape and the same size. The difference between congruent, so the symbol for that was congruent. The difference between congruent and similar is similar polygons or triangles have the same shape, that's the same, but their size can be different. It can be the same, but their size can also be different. So what this means is they are similar if they have corresponding angles that are congruent and corresponding sides that are proportional. So let's talk about what that means real quick. So for example, these are similar triangles. We can see that their angles have corresponding angles. So we have angle X and angle A are congruent. Angle Y and angle B are congruent. And angle Z and angle D are congruent. And we can see that since those angles are congruent, these are similar triangles, and their sides are then proportional. So here we go. If I change the proportion of the sides, say for example, we're at a dilation of 1, and a dilation of 1 says it's the same size. So if we go bigger, dilation of 2, which is double. I can't get it perfect. There we go. So this is double. So XZ is double of AD, ZY is double of DB, and XY is double of AB. These triangles are definitely not congruent anymore. Before, at 1, they are similar and congruent. Let's go on. Similar and congruent. They're same size and shape, which means they are congruent. They are also similar because they are the same size. They are the same shape. The same shape is what makes them similar. So if we go to 2, they're the same shape. The angles make sure of that, but the size is different. But the size is proportional. Each side has the same proportion of 2. See, XY over AB is 2, YZ over BD is 2, XZ over AD is 2. You can see that in the bottom. So that means it's still proportional, which means they are similar. That is basically what we're talking about here. So let's go back. So that's what it's talking about when it says corresponding angles are congruent. That was true. Corresponding sides are proportional. True. It dilated by 2. That's still proportional. So that's what similar means. So the scale factor, what we were talking about, since it got bigger by 2, the scale factor was 2. That is the ratio of the corresponding sides. That's what it showed at the bottom here. See at the bottom? XY over AB is 2, YZ over BD is 2. That is 2 is the scale factor. That's how much bigger it got. So our dilation is our scale factor. So look at the scale factor of these two triangles. Are they similar first off? Let's see. A goes with D. A corresponds with D, meaning those angles are congruent. B and E are congruent, and C and F are congruent, which means they are similar triangles. So we have to be able to see, are the sides proportional? Should be, but let's check. So what do we have to multiply 8 by to give us 12? So 8 times what gives us 12? X would be 1.5. And then we do it over here. 10 times what gives us 15? 1.5. And then let's do it over here. 14 times what gives us 21? 1.5. So what do you think our scale factor is? 1.5. So if we are going bigger, that means the scale factor is going to be bigger than 1. If we're going smaller, the scale factor is going to be smaller than 1. So we can set up our ratios with the image always on top. That's the way I do it. So image on top. So if we're going from ABC, this guy, to DEF, this guy, that means we're getting bigger. And the image is going to be on top. So let's take one side. It doesn't matter which side because they're all going to have the same proportionality. And let's do 12. So what side goes with 12? 12 is between D and E. And we know A corresponds with D and B corresponds with E, so it must be 8 for the pre-image. And what do we get? 12 divided by 8 gives us 6/4, which you know is 1.5. And is that our scale factor we got? It is. All right, so let's go back. What if we went the other way? Let's change it to green. What if the bigger triangle was our pre-image and the little triangle was our image? So our image always goes on top. So it doesn't matter which side we choose. Let's choose 10. So which side goes with 10? 15. They're between the same angles that are corresponding. Good. So 10 goes with 15, and what's that equal to? Divide by 5, 2/3. So that is equal to, as a decimal, 0.6 repeating, or 2/3. Both of these are good. Same with these. We could have reduced that to 3 seconds, but it doesn't matter. So let's figure out what the perimeter ratio is if we're going from the bigger one to the smaller one. So if we're going from the big triangle to the little triangle, that means, oops, let's first count the perimeter of the big triangle. The big triangle is 12 plus 15 plus 21. That's equal to, let's see, 27, 37, 47, 48. And the little triangle is 8 plus 10 plus 14. That is 24, 32. So we get always image over pre-image. So if we're going from the big triangle to the little triangle, it should be getting smaller. So we get 32 over 48. And that's going to be 16 24ths, 8 12ths, 4 6, 2/3. You could do that much faster, right? 2/3. Isn't that the same as we got for the scale factor from DEF to ABC? That's cool. So the scale factor is going to be the same as the ratio between the perimeters as well. That's nice. Okay. So we have to write a similarity statement for the triangles above. The way we do that is we write it as triangle ABC. This is going to be very similar to congruency. To triangle, what goes with A? D. What goes with B? E. What goes with C? F. And then instead of writing congruent like we're used to, we have a different symbol. We write it as this. Just the thing that goes on top of the equal. So usually congruent was this. Now we just get rid of the E. So usually congruent is this. Now we can just get rid of the congruent side. And there we go. There's similarity. Okay, so here we go. Similar to what we did in congruency, we have to show which angles are congruent, and therefore which sides are sorry, and then which sides are proportional, and that would show they're similar. Since we know they're similar, we're going the other way. So angle J, what goes with angle J? Tells us P. It's the order they put them. So angle J is congruent to angle P. Since these triangles are similar, change it. Then we know K goes with M. So angle K, M. And then L goes with N. So angle L goes with angle N. Okay, so we are going from the left one to the big one. So let's say this guy is our image. We don't know, and since we don't know, I would just choose one. Doesn't matter. Just make it consistent. So if we are taking side PM, what goes with PM? The blue and the red. So blue and the red would be J, K. And then we go, let's go NP. NP is the green and the blue. Green, the blue is LJ. And then we are going last side, NM. And NM is the green and the red. Green, the red is LK. And those all should be the same. Remember last time we got a scale factor of, depending on what direction we went. So before we got 1.5 and then 0.6 if we went the other direction. In our example here, we got 2. So see the proportions? 2, 2, 2 should be the same if they are similar. Okay? So number 2, same idea. Number 3, same idea. Number 4, here we go. If the figures below are similar with a scale factor of 2 to 3, find the value of x. So we're assuming this one's going to be the 2 and this one's going to be the 3. So if that is 42, what is x? We set it up. Which is our image? Doesn't matter. Doesn't matter which is on top in this case. We just got to make them consistent. So let's always put the image on top. Since we don't know the image, we just call this the image. So we go x is to 42 as 3 is to 2. And then we solve for x. Or we could have done it the other way. 42 is to x as 2 is to 3. Would it give you the same answer? It does, but let's check and see why. So if we did 3 times 42, would it still be 3 times 42 over here? Yep. And x times 2 would still be x times 2 over here? Yep. So let's do it. We get 2 times x equals 3 times 42. 2x equals 126. So x is going to equal 63, which means this side is 63. And does that work? Does 63 42 equal 3 halves? What would we have to multiply by? What would we have to multiply 40 to get this? So 21? Yeah, x would be 21. 21 times. Okay. There we go. So number 4, we got it. Number 6, here we go. Find the value of x. All right, let's call this one our image. Image. Doesn't matter. Let's put the image on top, which means it's going to be smaller. So our answer should be less than the other one. Or no, since we're looking for x, it's going to be bigger. But it doesn't matter. So here we go. So we have to find which side goes to which side. That's the important part for this. So A goes with D. B goes with E. B goes with E. And C goes with F. Okay, so let's set it up. So we're looking for x. So what does x go with? Does it matter if we put x on top or bottom? It doesn't, as long as we're consistent. So we're going to put this side always on top now, since we chose that. So we're choosing this as our image, I guess. So we're choosing this as our image. But it doesn't matter, like I said. So x goes with, it's between green and red. That's going to be 25. And then we have 28. That's going to be on top, since we chose x to be on top. And that's going to be between green and purple. Or no, pink. Green and pink. So that's 20. And then we solve. We cross multiply. We get 20 times x equals 28 times 25. X is going to be 28 times 25 divided by 20. So x is going to be, for number 6, 35. And does that make sense? 35, that's between green and red. Yep, 25 to 35. Yeah, seems about right. Let's check. Does 35 to 25 go with 28 to 20? If we simplified both, so what could we simplify this by? I don't know. Divide by 5, does that help? Yep, so divide by 5, that's going to give us 7/5. Divide by, I don't know, for this one. Oh, no, that's not going to be it. 7. So divide by 7. No, that's not going to be it. Let's just simplify. So we simplify, divide by 7, 5, that's going to be 7/5. Divided by, I don't know, 14 tenths, 7/5. Yeah, it ends up getting us to the same. 7/5, same proportion. So they're proportional. We're good. Our x, which is what we're looking for, was that. And we go. Number 8, here we go. Find the values of x and y. Okay, so setting it up again. That's important. Make sure your angles match. It's telling us the triangles are similar. So that means D goes with H. E goes with J. And F goes with G. Sometimes it's nice to do these in different colors so you can see it easier, but you don't have to. So we're looking for X. So X goes with, between red and green, 12. And we can't have two variables, so we can't use Y in this one. So we first got to find X, and then we got to find Y. So we have to use 15. So 15 goes with, between orange and green, that's 9. So there we go. 9x equals 180. X equals 20. So there we go. X equals 20. So now we can find Y. Let's do that in a different color. Black. So it doesn't matter. So Y goes with, between red and orange, that's 14. And then I can choose 20 now if I want, or 15. Doesn't matter. Let's use 15 again. 15, 9. So we get 9y equals 210. Y equals 23.3. So there are our two answers, and we're done. Let's go to number 10. If they are similar, find the value of x. Ooh, nice. This is a good one. So A goes with G. Sorry, A goes with K. Change colors. G goes with X. And M goes with D. So now we gotta find what is X. Same thing. So first, let's go with our 32. 32 goes with, it's between green and black. Between green and black is X plus 3. And then we got to use our other number we're given, 36. 36. Doesn't matter if we use 36 and 32 on top or bottom. We just got to make it consistent. Keep those triangles on, same triangles on top with the same triangle on the bottom. So 36 goes with between green and red, which is X plus 6. Since we still have X in both of them, we could solve for this. We're going to have to cross multiply. We get 36 times X plus 3 equals 32 times X plus 6. It's going to be some distribution practice. So we get 36x plus 108 equals 32x plus 192. Then we solve for x. Get the x to the left. We get 4x plus 108 equals 192. 4x equals 84. And then x equals 21. There we go. Not bad. All right, number 12. Here we go. So, if they are similar, sometimes it's easier if you break these apart, I find. So, when we get this in black, keep it consistent. We get B, N, V, and we get B, R, G. Sometimes that makes it easier. It does for me. So we have BV is 8, NV is 10, BN is 12, and that's it. Okay. And it tells us BR is 4x plus 7, and BG is 18. It tells us that right here. Okay, so let's match up the angles. B goes with B, obviously. N goes with R. And G goes with V. Okay, let's set it up. We're solving for x. So, what goes with 4x plus 7? That's going to be 12. Let's put 12 on top, which means this triangle is always going to be on top now. And that goes with 4x plus 7. And then it doesn't really matter which we use, or does it? It does, because we only have a and 18 that match up. 10, we don't know what 10 goes with. We don't know. So we have to use 8 and 18. And 8 goes on top because we have 12 on top. And that goes with 18. And then we solve. 12 times 18 equals 8 times 4x plus 7. Make sure you guys have parentheses when you're doing this. Doink, doink. All right, so 12 times 8 is, I think, 216. 216. And then we get 32x plus 56. 216 minus 56 is 160. And then x equals 5. There we go. Not too bad. Again, splitting the triangles apart makes this a lot easier at times. Okay, similar figures. I think I'm going to give you this for homework or classwork. So this, and I think I'm just going to give you the even or odd, and 9, 2. All right. Good practice. All right.